Hello students, this is the video lecture covering section 10.6, Circles and Arcs. Our learning goal for this lesson is to find the measures of central angles and arcs, and to be able to find the circumference and arc length of a circle. I'll apologize from the beginning here because this section does include a lot of vocabulary. Much of this information you already know, so make sure you copy down the information that you need. Our first problem involves naming arcs. So as you might recall from the previous slide, a minor arc is any arc whose central angle is less than 180 degrees. So this is any arc that is less than half a circle. So in this case, what I do is I choose a starting point like S, and I find all of the points that are less than half the circle around from S. So we could say that one such arc is SP. We could go from S to Q. We could go from S to R. If we choose P as a starting point and go to S, then it's the same as S to P. So we can go from P to Q. If we go from P to R, it looks like that's halfway around the circle, so we can't do that one. So this is the only one that starts with P. If we start at Q, we can go from Q to P, but that's the one that we just did. We could go from Q to R. Semicircles, now that we have half of a circle, we need 3 points. So one semicircle could be from P through Q to R. And the other semicircle would be from P through S to R. So a major arc means that we need more than half the circle. So if we start at Q, we could go through R to S. So we have Q, R, S. We could start at Q and go through P around to R. So we could Q, P, S. If we include Q in the middle, then we could start at P, use Q and S, so we could have PQS. That would be this arc. We could start at R, and go through Q around to S, so we could have RQS. And so hopefully you get the idea of major arcs. So one of our key concepts of this lesson is arc measure. So the measure of a minor arc is the measure of its corresponding central angle. So just like we had central angles with regular polygons, we have those with circles as well. So in this case, we would say that the measure of arc RT is 50 degrees. Now when we talk about major arcs, in most cases it's easier to do 360 minus the measure of its related minor arc. So in this case, to find the measure of arc TQR, we take 360 and subtract from that the measure of arc RT. So 360 minus 50, which gives us 310. All semicircles have a measure of 180. So just like we had adjacent angles, we now have adjacent arcs. They are two arcs that have exactly 1 point in common. So in this case, if you want the measure of arc ABC, as you can see in postulate 10.2, the arc addition postulate, you take the measure of arc AB and add that to the measure of arc BC. So let's find some measures of arcs. Here, if we're looking for the measure of arc PR, we go to the central angle and we find that the measure of arc PR is 77 degrees. If we want the measure of arc RS, we're looking at this arc here. So we need that central angle. And it looks like PS is a diameter of the circle. So in this case, I would do 180 minus 77. And I would say that the measure of arc RS is 103 degrees. If we want the measure of arc PRQ, We're going from P through R all the way around to Q. So we're looking for this piece of the circle. So we have 77 plus 103 plus 28, or we have a total of 208 degrees. And if we want the measure of arc PQR, we're going from P through Q all the way around to R. So we want this piece of the circle. So in this case, probably best to do 360 minus 77, which gives us an arc measure of 283 degrees. Circumference, something you guys should be familiar with. The circumference of a circle is the distance around a circle. So we finally get introduced to the number pi, which is the ratio of the circumference of a circle to its diameter. So here we have two formulas for the circumference of a circle. Circumference is pi times the diameter, or 2 times pi times the radius. So coplanar circles that have the same center are called concentric. So concentric means same center. So let's draw some circles with the same center to see what they look like. So we choose one radius, and we draw a circle. Let's change the color. Let's draw another circle with the same center, different radius. Let's change the color. Choose another radius. Draw a circle. So here you can see that concentric circles form a bullseye. So question number 3 says that a car has a circular turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. And we're trying to determine how much farther does a tire on the outside of the turn travel than a tire on the inside. So this is a circumference-based question. We know that circumference equals 2 times pi times the radius. Okay, so let's go ahead and calculate one circumference in red and the other in green. So the circumference of the red circle is going to be 2 times pi times the radius, which is 16.1. So multiplying this out on the calculator, 2 times pi times 16.1, rounded to the nearest tenth, we find that this is about 101.2 feet. So now let's calculate the inside circle. First we need to know the radius. So we can see that it's going to be the 16.1 subtract the 4.7. So now we have 2 times pi times 11.4, which is the radius of that interior circle. And so when we multiply this out, we find that this is about 71.6 feet. So when we find the difference here, how much farther does a tire on the outside travel? It actually travels almost 29.6 feet farther on the outside. So interestingly, if you were to just drive in circles, those outside tires would wear out considerably faster. So the measure of an arc is measured in degrees. However, arc length is a fraction of a circle's circumference. In addition to that, congruent arcs are arcs that have the same measure and are in the same or are in congruent circles. So in order to find arc length, we take the measure of the arc divided by 360 and multiply that times the circumference of the circle. So let's go ahead and calculate some arc lengths. And you'll notice here, we're going to leave our answer in terms of pi. So in this first case, we have a 90-degree angle. So we're going to take the measure of the arc that we're looking for, divide that by 360, and we're going to multiply that times the circumference of the circle. In this case, since we have a diameter, I'm going to use pi times the diameter, or pi times 16. So the first thing I'm going to do is reduce that fraction. 90 over 360 reduces to 1 over 4. And continuing to combine like terms, 16 times 1/4 gives me 4. So this arc length is 4 pi inches. For the second arc length, we're going to take the 240 degrees, divide that by 360. We're going to multiply that by the circumference of the circle. In this case, we're given a radius, so I'm going to use 2 times pi times the given radius, which is 15. 240 over 360 is the same thing as 2/3. 2 times 2 times 15 gives me 60. And 60 divided by 3 gives me 20. So this arc length is 20 pi centimeters. That concludes this video lecture on section 10.6, circles and arcs. Hopefully you took the time to copy down all the postulates and the vocabulary. Thanks for your attention, and I'll see you soon.